Hey everybody, the purpose of this video is to get you some solutions to the Chuck-a-Luck ante quiz. We have the game of Chuck-a-Luck, which involves throwing 3 dice, and we're betting on one of the 6 numbers that can appear on any single die. We decided to bet on 5. It doesn't matter if you bet on 5 or 6 or 3. They're all the same. They're all 1 and 6 likely on each of the 3 dice. In class, we played with this game quite a bit a couple classes ago. If you bet on 5 and you throw 3 dice, you're either going to get 0 5s. You might get like a 1, 2, 3, or a 3, 4, 6, or something like that. You might get 1 5, 5, 1, 1, in which case you should have bet on 1. 2, 5, 4, something along those lines. You might get 2 5s, 5, 5, 1, 5, 5, 2, etc. Or you might get all 3 5s, which is the big win. Now in class, the way the game is traditionally played, you bet $1, and then that's your ante. So the normal ante is $1. If you don't get any 5s, you lose your ante. If you get 1 5, you win your ante back. If you get 2 5s, you win your ante back plus 1, and if you get 3 5s, you win your ante back plus 9. So the payouts are 0 to 1, 1 to 1, 2 to 1, and 10 to 1. I've seen them changed in various scenarios, and it doesn't matter. As long as you know the payout, you can figure out what the average payout is. So the question is, I want you to adjust the ante on this one. So I got you started on the quiz by telling you that if you don't win, if you roll no 5s, your payout, which is X here, is opposite A, or negative A. That's because you lose your ante. And you gain, you imagine a 0 in front of there if you want. You gain nothing and you lose your ante. So what you end up taking is the difference. That's why this is 1 minus A, because you win back $1 but lose your ante. Now make peace with those two from class. In class the ante was 1. So this is negative A, or negative 1. This is 1 minus 1, which would be 0. In class the next one was 1, because it was 2 minus 1 is 1. Now it's 2 minus your ante. And this is 10 minus your ante. So letting A equal 1 in all of those gets you negative 1, 0, 1, and 9. Letting A equal, say, 4 in those would be negative 4, negative 3, negative 2, and 6. And also nobody play the game because you'd be losing except for this right here. Just so you know, these are the probabilities. They probably look a little different than we did in class because they're binomial. If you're interested in the binomial derivations of these, I'll give you real quick ones here. The binomial derivations are fairly straightforward. In order to not get 5s, that means you have to roll 5/6 probability 3 times in a row. If you multiply this out, you get 125 over 216, which is that to whatever made decimals. Down here, it'd be 1/6 cubed because you have to literally get the 1 in 6 each of the 3 times. And then the 2 in the middle just become some variant of 5/6 and 1/6. I'm slamming these in here pretty tightly, and I apologize. So here you have to get 1 5 and 2 non-5s, and here you have to get 2 5s and 1 non-5. And I apologize for crushing that in the side there, but the point of this quiz isn't to derive these, it's to start with these. These are in another exercise from the binomial distribution. So anyway, you've got everything you need. You've got everything you need now to get going on this. So in order to figure out what the ante is to make the game fair, you have to take the average of this distribution. And the distribution is this bit right here. Just those 2 columns. That was just a guide, and this was just in case you were wondering. So the idea is you have to now create an equation. So an average of a distribution is going to be the sum of each payout times its probability. Okay, that's what an average is. In this particular one, you take each payout times its probability, 0.578704, plus the next one, 1 minus A, times 0.347222, plus the next one, 2 minus A, times 0.06944, plus the last one, 10 minus A times its 0.00463. Okay? Now, as you might notice, that is just an expression. But to make it fair, that needs to be equal to $0. Because the point of a fair game is you don't lose money on average and the casino doesn't make money on average. Now you know that on average the casino does make money on this game. I believe it's about 47 cents per game they make off of you. So essentially, you walk up, hand them $1, and they give you 53 cents change. They keep the 47 cents from you, right? And hopefully that makes sense. They keep the 47 cents, and you get the 53 cents back. Okay, which means you're losing that money as a result. The idea now is you have to solve this equation. Now this is a fairly simple equation to solve. It looks awful. I mean, it totally looks awful. But setting these two things equal together, and again, if you need more, I'm out of board, and I don't want to erase the board to erase everything else we've already written. But if you want to erase, if you want to solve, if you need help solving this, just ask me. It's a little bit straightforward, actually. We could probably get a little bit clever about this, maybe. No, not really. Because if we take the a's, there's a negative a times each of those probabilities, which means there's going to be negative 1a. And then we're going to have that one, 2 of that one, and 10 of that one. That's going to be a little bit messy. We can kind of reason through it, though. I'll give you the answer, but I'll give you a quick, rather than just blowing through the algebra, we can kind of reason through it a little bit. 2 times that is about 14 cents. 10 times that is about 0.4 cents, you're 14.5 cents. And 1 times that is about 34 plus the 14 is about 48 cents-ish, give or take. So you're going to end up with rough, this is all very rough math, I would say check the math on this one for sure. But what you're going to end up with is A should be about 47 cents, okay? And that should make sense, because if they are keeping 47 cents from you on average in the normal game, that means they should be giving it back to you as an ante to make the game fair. Think about that again. If they are keeping from you 47 cents on average with the way the bet is with the dollar, they should be giving that back to you in the case here. Hopefully that makes sense. Hopefully I believe that makes sense. So at any rate, you can go ahead and solve this any way you really kind of want to. But this is just one way of slamming it out, kind of keeping track of that. Fair enough? Hopefully. See you in class.